So we started with continuity and differentiability, right?
Yes, sir. Good evening, sir.
Yeah, good evening. So I asked you to write down the concepts. Did you all write down? Yeah. So I asked you to write down the concepts, no? So what were the concepts? I checked all your assignments, like things that you have uploaded. One is differentiability, right? Then is differentiation of. No, I'm not talking about that. Like what were the concepts I asked you to write? Differentiability. I could see, like I told you to write till implicit functions. Implicit functions and inverse trigonometry also. Right? Did you all make a note of it? Yes? Okay. So tell me, what is differentiability? What do you mean by differentiability? Check your notes and tell me. Okay, that is differentiation. Right? What is differentiability? The name of the chapter. It is continuity and differentiability, right? So what do you mean by differentiability? If you take a function at a particular point, when will you say it is differentiable or not? Like when will you say it is continuous in the first place? I gave you certain set of rules. Now what were they? Left limit should be equal to right limit, should be equal to the function value. That is one way. That is a concept borrowed from your 11th standard basics. But this year there is another theorem that says limit extends to a f of x is equal to, or limit extends to c, f of x is equal to f of c. If that is satisfied also, you say that the given function is continuous where? In its domain. Right. Now the next question is, when will you say that a function is differentiable at a given? That is what I'm expecting. So if you find the left-hand derivative, if that comes out to be equal to the right-hand derivative, and that should be equal to the, it should be the derivative at that point. F dash of, for example, it is not x, it will be f dash of c. Am I right? So this is how it works. So to visualize it, if I take the function to be like this, then what do you first draw? You draw a line. What is the name of that line? You will not directly not draw a tangent. You will first draw a secant, right? You will draw a secant in such a way, if you take this point to be, if you take this point to be C, right? What will be the corresponding point here be? C comma f of c. Okay. If I take a point here which is c minus h comma 0, what will be the corresponding point on the y-axis? C minus h comma f of c minus h. See, whatever is there here, you will substitute it in the place of x. Right. So what is the slope of the secant? If I take this to be the secant, what is the slope of the secant? What is slope of a line? y2 minus y1 by x2 minus x1. So what will you write here? F of c minus f of c minus h divided by. So how much will you get? Right. If I write it like this, I'm getting a slope. What is the name of the slope? It is the slope of the. It is the slope of the secant. When will the secant become a tangent? When this point A is very, very, very close to point B. When it becomes very close to point B, means when it keeps moving, when it comes here, right? When you try to draw a secant, that secant will look like a tangent, right? So this is slope of secant. For the slope of secant to become a slope of tangent, what am I supposed to do? I need to apply the limit. What should tend to 0? Limit h tends to 0. Means when h is tending to 0, c minus h will be close to c. So limit h tends to 0, f of c minus f of c minus h the whole divided by h is going to give me the left hand derivative. Right, this is what you would have written. It is going to give us the left hand derivative. Similarly, if I want the right hand derivative, see, it's already in your notes, I'm not giving time to write. Okay, if you want the right hand derivative, then what are we supposed to do? You'll take something like this, you'll take the point C here, then C plus H comma, f of C plus H will be here, here it will be C comma, f of C, drop a perpendicular. Then what will be the slope of the secant? Again, you will have a secant. What is the slope of the secant? F of C plus H minus f of C again by H. This is the slope of secant. If I add a limit to this limit, H tends to 0, then this becomes the. So basically, why do you differentiate? To find the slope of a tangent to a curve at a given point. So this is the right hand derivative. So for the function to be differentiable, left hand derivative should be equal to the right hand derivative. See, the same thing you would have learned last year as the first principle of derivative. You remember? So it's called as the first principle of derivative. If you have not heard of it, this is the basic definition of differentiation. Okay. Then I'll have f dash of C. So the meaning of f dash of C is at point C, I'm drawing a tangent. Right? So all the three should be the same. Then the function is said to be differentiable. Can we take an example and do? Can you give me an example of function which is differentiable at a point? But before that, one condition that should get satisfied is for a function to be differentiable at a point, it should be continuous. So this can ask as an assertion reason question. Is every continuous function differentiable? No. Listen to my question here. Is every continuous function differentiable? No. Is every differentiable function continuous? Yes. Are you able to understand? So somebody tells you that this function is differentiable at a point. By default, they are telling you that it is continuous. But somebody tells you it is continuous, you cannot conclude it is differentiable. Am I clear with that point? Let's take an example. So if I take y is equal to x square. Okay, I'm taking y is equal to x square. And I'm going to check the differentiability of this function at x is equal to 0. So first thing, if the function has to be differentiable, what did I say? It should be continuous. Is this function continuous at x is equal to 0? It is. Now you know how to check the continuity. I'm not concentrating on it. Now I'm only concentrating on the differentiability. So for differentiability, I'm taking the left hand derivative. So what is the left hand derivative? Limit h tends to 0, f of c minus f of c minus h. How many of you are checking your notes and telling me that? How many of you know how to remember this? See, it is very simple, right? You start from right. So it is basically like this. If you take a number line, if this point is c, this point is c minus h, and this point is going to be c plus h. So if at all you want to find the left hand derivative, then what you need to do is always come from right to left. So what is the point on the right? C. So start with c minus c minus h, and the denominator is always h. So f of c minus f of c minus h divided by h. You're able to understand? So similarly, if I want the right hand derivative, what will I do? So start from right to left. So f of c plus h minus. That's what you need to remember. Okay, there's not a formula or something. There's derived part. So f of c minus h divided by h. So here, what is the value of c? C is 0. C is the point. F of x is a function. X square is f of x. Here. So limit h tends to 0. Now tell me what is f of 0? Take this and substitute it here. 0 minus, what is f of 0 minus h? In the place of x, I'll substitute 0 minus h. Got it? The whole divided by h. Okay. So don't directly substitute the limit, you will get 0 by 0, which is not defined, right? So this will be equal to limit h tends to 0. What will you get here? 0 is 0 only. Minus this value is h square. Minus h square divided by h. H and h will get cancelled. So now you substitute the limit. It is 0. Are you able to understand what I did? Right? So first copy this. I'll give you 2 minutes time. Do the right hand derivative and show it to me. Zero is right. How did you get it? Right hand derivative. H or other. Limit substitute. Shall I proceed?
Yes, sir.
Okay. So what is the right hand derivative of this function? Limit h tends to 0. F of c plus h
Minus f of c
by
divided
h.
by h.
So here f of x is x square and x is equal to 0. C is 0 basically. So limit h tends to 0. Vaishnavi, can you tell me how to do? In the place of c plus h, what should I do? So 0 plus h the whole square minus f of 0. Correct. 0 divided by. So limit h tends to 0. H square divided by h. So this is going to be limit h tends to 0. One h will get cancelled. H. Then you will substitute the 0. You will get a 0. Right. So if f of x is equal to x square, I am assuming everybody moves the basic differentiation. What is f dash of x? 2x. So after this, if I ask you what is f dash of 0, what will you see? Wherever 0 x is there, substitute 0. You will get a. So what is happening with this function? It is differentiable at x is equal to 0. Am I clear with this? Right. Okay. So before you copy the same question, I want you to check whether it is differentiable at the point x is equal to 1. We did for 0, no? C is 0. Now you try the same problem with x is equal to 1 and tell me what is the answer. X square, same function. not differentiable. Correct, Abanya? Shall I proceed?
Sir.
See, listen. If I take y is equal to x square, right? For left hand derivative, limit h tends to 0, f of c minus f of c minus h the whole divided by h. Makes sense? So what should I do? Limit h tends to 0. What is f of 1? I substitute 1 here, 1 minus of the whole divided by h. Right. So then what will you have? Limit h tends to 0, 1 minus of 1 plus h square minus 2h divided by h. So 1 and 1 will get cancelled. So what is common in the numerator? Take that h outside. You will have limit h tends to 0, h into minus 1 plus 2. Sorry, minus h plus 2. Okay, you kept the minus outside. Correct? So I took the h outside, the minus is there. So minus h into h minus 2, the whole divided by h and h get cancelled. Substitute the limit. So what will you get? Minus of minus 2 is 2. Am I clear with this? So you get the left hand derivative as 2. Okay. So what about the right hand derivative? So right hand derivative is limit h tends to 0, f of c plus h minus
F of C.
by h. Right. So limit h tends to 0, f of c plus h is 1 plus h the whole square minus 1 by h. Actually, it is 1 square for your clarification. So it is like this. So this will be limit h tends to 0. 1 plus h the whole square is 1 plus h square plus 2h. 1 plus 2h. You have a minus 1 divided by h. 1 and 1 will get cancelled. What is common number? H is common. So when you take out that h and h will get cancelled. So what is that you're left out with? So you're left out with limit h tends to 0, h into h plus 2 divided by h. H and h will get cancelled. Answer. So what can you conclude from this? Left hand derivative is equal to right hand derivative, but that's not sufficient. So what should you have? So f dash of x is how much? Derivative of x square is 2x. What is f dash of 1? That's the answer. So all the three are same. Hence, it's a differentiable function. Okay. Clear with this?
Yes, sir.
Yes. Shall I proceed? Anger. Minus is there outside. No? 1 and 1 got cancelled. So if you expand this, you will get 1 minus 1 minus h square plus 2h. 1 and 1 are gone. Take that h outside. So you have 2 no plus 2. Clear with this? Now see. Shall I proceed? Now see, if I take the function y is equal to mod x, we need to check whether this function is differentiable at x is equal to 0. So we need to check the differentiability of the function y is equal to mod x at x is equal to 0. So how to do this? So first, define the function f of x is equal to x when x is greater than 0, 0 when x is equal to 0, minus x when x is less than 0. So when I take the left-hand derivative, right? When I take the left-hand derivative, what will I get? Limit h tends to 0, f of c minus h the whole divided by h. Okay. So this will be equal to limit h tends to 0. What is f of 0? Minus for f of c minus h means what? F of 0 minus h means x is taking a negative value. So what function should I consider? When x is less than 0, minus x is what we need to consider. So what should I write there? See, this minus is in the formula. What should I write there? Am I right? Why did I put this minus? Because I took this function. The whole divided by. So what will the answer be? So observe limit h tends to 0, 0 minus this. So minus of minus h is plus h, plus into minus is again minus. So minus h divided by minus h is, this will get cancelled. You will get the answer as minus 1. So have this in your mind. Am I clear with the steps? I'll give you time to copy. Am I clear with the steps? No.
Yes, sir.
Now listen to this. If I ask you, what is the right-hand derivative of this function? What will you write? Limit h tends to 0, f of c plus h minus f of c, the whole divided by h. All right. So limit h tends to 0. What is f of c plus h? What function should I consider? So c plus h means 0 plus h. So 0 plus h means I'll take x. So f of c plus h is 0 plus h minus f of c. F of 0 is 0, the whole divided by h. So you're left out with plus h here, plus h divided by h. Right? So what will you get? So what is happening in this case? If you observe,
left-hand derivative is not equal to right-hand.
Left-hand derivative is not equal to the right-hand derivative, right? And if you look at the derivative at that point, if you take f dash of 0, it will come out to be 0. Sorry, f dash of 0 will come out to be 1. F dash of 0 will come out to be 1. The meaning of this is, listen to this carefully. Now I'll explain what is the actual meaning of differential. Observe this. It's very careful. It's very important. What was the first function that I took? Y is equal to x square we took, no. So we checked the differentiability of the function at 2 points. What was it? One was at 0. See, I gave you the point 1 to make you get used to the formula. Now I'll tell you what is the significance of it. Listen to this. If I drop a perpendicular here, if I take this point to be 1, 0, what is this point? It is 1, 1 basically. So if I take this pen to be the tangent, whether I draw a tangent to this curve at point 1 from the right hand side or left hand side or exactly at that point, all the three are the same. Am I clear? So what I can do is, if I ask you to draw a tangent to it, you can draw it in any way you want. You can start from here. If you start from here and draw a tangent, or if you start from the bottom and draw a tangent, or you directly place a tangent, you take a tangent, just stick it there, all the three will overlap. That is the meaning of differentiable at that point. Whereas when I took y is equal to mod x, right? You look at the shape of this, it is going to take this V shape. Right? We know the graph of mod x. When I draw that tangent, see here, there is no curve in the first place. The line itself is a tangent. So wherever I say slope, what is the meaning of slope? Slope is the angle, tangent of the angle made by the line with the x-axis. You know the basic definition of slope, right? You write tan theta. What is that theta? Angle made by the line with the x-axis in the positive direction. It's not positive x-axis, it is positive direction. Meaning this line is making an angle of 45 degrees. This line is making an angle of 135 degrees. Means the angle between them will be 90. So what is the slope of this line? Tan 45. So slope of this line is tan 45. Slope of this line is tan 135, which is -1. That is why the left-hand derivative was -1. The right-hand derivative was +1. Are you able to understand what I'm saying?
Sir.
That is the actual significance of differentiability. So this is one of the best examples of a function which is continuous at a point, but not differentiable at a point. Meaning you cannot draw the same tangent to this curve from both the directions. Am I clear with that? Right? So please make a note of this. I'll tell you a shorter way to solve this. You need not do all these things. I'll tell you a shorter way, but don't use it for the exam. CBSE examiner, don't use it. I'll write that also on top. Otherwise, people will use and come and tell me. I'll tell you a shorter way to find whether a function is differentiable or not. Okay. So first write it down. You can do it in one step. I hope I'm clear, right? As well. Function value is 1. I didn't say function value. Function value is 0. Where did I write 1? I wrote f dash of 0 as 1. Because f of x is defined like this. X when x is greater than or equal to 0, minus x when x is less than 0. So you directly differentiate this. So derivative of x is 1. That's why I wrote it. Okay. From here, make it worse. So write it down. See, once they have completed this, no test and expert. I'll just spill water. See, once you are done copying the slide, let her know. Okay. You're done? See? Done with this? Okay, listen. See, whenever you know a function is continuous at a point, by looking at the function, you can just tell whether it is differentiable or not in one step. So how you can do that is, suppose I have a function like this, f of x is equal to mod x. Then how do you split this? F of x is equal to x when x is greater than 0. Okay, I'll write x greater than or equal to 0. Negative of x when x is less than 0. Right? See, directly differentiated. If I do f dash of x, what is the derivative of x? 1 for the same limit. This is minus 1 for the same limit. Look at them. Is this not what we got? Right hand derivative and the derivative of the function at x is equal to 0 was 1. Left hand derivative was minus 1. So you can directly look at this and tell whether it is differentiable or not. You can use it for competitive exams. Don't use it for CBSE. If they ask you, you have to write those steps. Okay. So what we'll do is we'll try out few more problems from this exercise. Can you open your textbooks? See, if you look at, you go to page 122, exercise 5.2, look at problem number 9 and 10. So what is the ninth problem? Page 122, exercise 5.2, no? What is the problem number 9? So what are they asking? To check the differentiability, or they are asking to prove something? See, by default, if you see a modulus function, it is not differentiable. Modulus function is continuous but not differentiable. Okay. So for the sake of understanding, I'll tell you how to split this function. I repeat it. The way I'm going to split it here is important for another part in calculus. So observe this carefully. Okay. It's important for definite integrals. So observe, if there is any doubt, ask. Now see, inside a modulus, whatever function, whatever expression you have, right? Till you get used to it, imagine it to be capital X. See, had the function been modulus of capital X, how will you split it? Capital X when capital X is greater than or equal to 0, because this function should be greater than or equal to 0, minus of capital X when x is less than or equal to 0. Makes sense? If that is the case, then how should I write this function as? I should write it as just x minus 1 when x minus 1 is greater than or equal to 0. I should write it as negative of x minus 1 when x minus 1 is, less than 0. Right? An extra step. What will you have? The same thing, x minus 1 when x is minus of x minus 1 when, that's it. That's all you need to do. Okay. So even before you start solving, if suppose here they have asked you to show that it is not differentiable, they ask you to check the differentiability of the function. What did I tell you? Directly differentiate this and see. Do that as a rough work. Is this function differentiable? So what is the derivative of x minus 1? It is 1. Derivative of x minus 1 is 1. Derivative of minus of x minus 1 is minus 1. So it is not differentiable. Right? That is what you need to prove. Means when you find the left hand derivative and the right hand derivative, they should come out as minus 1 and 1 respectively. But where will you find those derivatives? At which point will you break? You need to say that this function is not differentiable at 1. At all other points, it will be differentiable. Because at x is equal to 1 only, it is taking a turn. You saw that V shape, no, it is coming down. At x is equal to 1, it will take a turn. See, for example, if I have to explain how this graph is, can you all try drawing the graph for this? It's a V shape. Modulus is V shape. But which side will you have? You draw it in your notes and just show it to me. If you're not confident, draw it in the back side and show it. Okay. 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 You? This. Small. We'll have some guess, no? What about you? உனக்கு என்ன தோணுதோ வாங்கிட்டு வரேன் உனக்குள்ள இருக்கிற பிகாசோ வெளில பண்ணுறோம் மேலேயா ஓகே வாட் அபவுட் யூ சேம் அவ தான் சொன்னான் ஷூர்லி டோல்ட்னு மேலே தள்ள அப்படியா சார் வாட் அபவுட் யூ ஷோ நோ இட்ஸ் ஓகே டு மேக் மிஸ்டேக்ஸ் ஷோ யூடா பிரணவ் okay what is that point Aditya Kalpakesh right is that how it works sure okay you also came so 1 2 and 3 of them are right so most of you what you have done is shifted upwards. It's very simple, okay? See, you need to substitute that value of x where the function will become 0. What is the value you will substitute? X is equal to 1. So at 1 it is going to be 0 means from here draw the V shape, you're done. That's all. First one, how will I know? I didn't see that. So this is the graph. So this one will be x minus 1. This will be negative of x minus 1. Obviously, it is not differentiable. Okay. Right. So let's see how to find the left-hand derivative for this. What is the function value? F of x is equal to x minus 1, negative of x minus 1. When x is greater than or equal to 1, x is less than 1. So what is the left-hand derivative? Limit h tends to 0, f of 1, I'm directly writing it, f of 1 minus f of 1 minus h, the whole divided by h. So limit h tends to 0, what is f of 1? 0. F of 1 minus h. On the left of 1, what is the function? Just now we drew the graph, no? So this one, negative of x minus 1, I need to take this function. So minus of 1 minus h minus 1. The whole divided by h. So limit h tends to 0. So how much are you going to get? 1 and 1 will get cancelled. Minus of minus plus into this is minus h divided by h. Answer will be minus 1. Is that what you are supposed to get? When you differentiate that, you will get minus 1. Okay. Similarly, what about the right-hand derivative? Limit h tends to 0. F of 1 plus h minus f of 1, the whole divided by h. So what is f of 1 plus h means what function you will take? You will take x minus 1. So what will you get? You will get 1 plus h minus 1. So you will have 1 plus h minus 1 minus 0. F of 1 is 0. Right, f of 1 is 0. The whole divided by h. So 1 and 1 will get cancelled. H by h is 1. So limit h tends to 0, 1 is 1. So left hand derivative and right hand derivative are not same. So for this, these steps are expected. Okay, so you need to write them. Here, that graph, that is mod x plus 1. So you take mod x, you shift it by 1 unit in the upward direction. Mod of x plus 1 kadayadu. Mod x plus 1. Clear? Look at the next problem. Look at the next one, 10th one. So what are they asking? Prove that greatest integer function is not differentiable at x equal to 1 and 2. See, look at the domain of that function. What is the domain? They have defined it for this problem. What is the domain? X lies between 0 and 3 open interval. So what are the integers that are included? So the real numbers that are included is greater than 0, less than 3. Among that, what is the integer value you will take? 1 and 2. So how to solve this? You can just tell it in one step. Why? It's not. It's not. That's the answer. Just because it is not continuous at the integral points, it is not differentiable. That's it. So for a function to be differentiable, what is that we need to check? Continuity. So continuity itself fails. Then where is the question of differentiability? So since the greatest integer function is discontinuous at integer points, it is not differentiable at 1 and 2. Here. Okay. So just to understand differentiability, what you can do is, here all you can go to page 117. But unfortunately, they are all not continuous. So go to page 116, look at problem number 10, 11. Look at problem number 10 and 11 and tell me whether they are differentiable or not. So problem 10, first check the continuity. Is it continuous? Problem number 10, is it continuous? Yes, it is continuous. Is it differentiable? You need not do the left hand derivative or right hand derivative. Just tell me by looking at it, how will you say? It is differentiable. Check. You will get the left hand derivative as 2. X is less than 1. Left hand derivative will be 2. Right hand derivative will be 1. 2x plus derivative of 1 is 0. So you'll get only 2x. So in the place of x, you will substitute 1. Whereas for right-hand derivative, you will get only 1. So it is a continuous function, but not a differential. It's not a differentiable function. I was checking if there are any functions which are continuous but not differential. The 11th one, I don't think it is continuous at all. 11th one is not continuous, huh? No, it is not. All are not continuous functions. So look at the 16th one. Look at the 16th one and tell me whether that function is differentiable or not. So for differentiability, first check the continuity. So 16th one is a continuous function. Huh? Where will you check the continuity? What are the points at which you will check continuity? You will check at -1 and 1 because that is where the function is broken. So when you look at 16th one, is it continuous at -1? Yes, it is. Is it continuous at +1? Yes. But is it differentiable? No, it is not. So going forward, what you can do is you can try drawing the graphs. So 16th one, what is the function? F of x is equal to -2, 2x and 2. So this x is less than or equal to -1. Correct? So this x is greater than -1, less than 1. This x is greater than or equal to 1. So when you draw the graph, correct? Okay. So if you draw the graph for this is x-axis, this is y-axis. So when x is less than -1, this is where the cutoff point is, -1. On the left of -1, what do you have? You have -2, which is a constant function. The graph will be like this. 2x is a line which is passing through the origin. But where does it start? So wherever the left limit of -1 ends, the function value starts from there. Because you substitute x is equal to -1, it is still -2. At x greater than -1, it is still -2. So the graph will look like this. So after that, x greater than 1, it is 2. So x less than 1, it is 2. X is equal to 1, it is 2. So the function is continuous, but it is not differentiable. Because when you come from this side, whenever you have a sharp point, right, it will not be differentiable. That is what is happening with mod also. There is a sharp turn. Wherever two lines meet like this, it will not happen. It will not be differentiable. Are you able to understand? So here also, if you see, this is the slope of the line. For what is the slope of this line? It is parallel to x-axis. What is the slope of this? 0. What is the slope of this? 0. What is the slope of this? 2. Y is equal to mx. M is 2. You're able to understand? So slope is 0, 2, and 0. That is why it is not differential. Clear with this? Okay. So this is how differentiability works. See, that is one of the, I'd say, slightly toughest concept. But I hope you could understand, right? You're able to visualize, know what it is. After this, everything is formula and you need to simply keep differentiating. They'll give you one function, differentiate. That's it. After this theory is over. Okay, it's only about formulae, applying it. I think I asked you to copy till inverse trigonometry, right? So in this exercise, you have a chain ruler. I won't remember which exercise. 5.2, you have chain rule, no? Yeah. So 5.2 is chain rule. Then you have implicit functions and inverse trigonometric functions. So Till there, if you have copied everything, no, tomorrow we'll do problems. Can someone tell me what is the difference between implicit and explicit? So basically, you cannot write it in the form of y is equal to f of x. You cannot separate the dependent and the independent variables. So whenever you have implicit functions, what will you do? You will start differentiating directly. Whereas when you have explicit functions, left hand side will be dy by dx, right hand side you will differentiate it separately. Right? On avliya. Mobile on avliya. Okay. So that's it for today. I'll see you all tomorrow. See, is it holiday for everyone? May 12th, Nane close. அதுக்கு முன்னாடி எனக்கு it is holiday, I thought I'll take it in the morning. அப்படியா? Till what time?